responsible for the sales and business of Lindemann in Middle East, India, Turkey, and North Africa. So as mentioned, I have been involved closely with the Ministry of Steel in India, with MRAI and Niti Aayog, FICCI, and several government organizations and entities. And I have seen the recycling activity develop over the last decade. So I have been with Lindemann for 11 years now, and involved in installing several equipment across India and also around the world. So we have commissioned our first shredder, for example, in Delhi. We have a shear in Noida. We have some baler in Chennai and Raipur, and now also Jamshedpur, and all across the country. So thank you very much. And today I'm a mechanical engineer by profession, and with an MBA in marketing. So today I will touch upon the technological aspects of recycling and how automation will help improve recycling of aluminium.
Okay, Mr. Keegan, let me introduce all the other people. So then we start with you. So Chouhan sir, people are knowing about you very well, but it will be better. I'm very much aware of your activity and all. You are doing a great job for the aluminum industry in JNARDDC, and I have get the opportunity to visit 3-4 times to JNARDDC. Anyway, but it is better to be explain yourself and your position. Please, Chouhan sir.
Thank you, Rajpurohit ji, and the way you said, like you know JNARDDC, and of course you know me personally. But for the forum sake, I would like to introduce myself. I am Ram Chouhan, R.N. Chouhan, working as a senior principal scientist in JNARDDC. नाम बहुत लंबा है, लोग अक्सर कंफ्यूज होते हैं कहने में. By the way, it's Jawaharlal Nehru Aluminium Research Development and Design Center. It's an autonomous institute under Ministry of Mines, Government of India, and dedicated to the research in aluminum related activities. And I'm heading the downstream division, which looks after the metal related work, be it forming or casting or characterization or recycling, in fact. And this institute is recently nominated by Ministry of Mines to work as a metal recycling authority. And prior to this nomination, we took up one survey of aluminum recycling industry with support of MRAI, where Dr. Rajpurohit ji was personally involved, and he helped our team a lot because of course during that time pandemic, lockdown, and the all adverse situations, but still we could move around the country to all possible within the possible limit, and he arranged the meetings with the recycling industry, and we had a really good picture of recycling industry to understand better. And now, since the ministry has nominated this institute as a metal recycling authority, we have those background images of the recycling industry and how or what best we can do for the industry as a metal recycling authority. That is what we are working with ministry, as well as we are taking help of MRAI time to time. And also with regard to the circular economy aspects or the agenda of Government of India, once again JNARDDC is nominated to work for the various action points in a circular economy. One of the action points specifically is the zero waste policy for the metal sector, where we are dealing with the aluminium, lead, copper, and zinc, 4 metals, primary as well as secondary, and arranging conferences, meeting people, bringing awareness about circular economy. And then even one of the very recent, just 2 days back, we received communication from this NDC, this National Council Skill Development Council, and they are willing to involve JNARDDC for skill development for the industry sector, so that the right kind of people will be available for recycling industry. So that's the brief. Maybe when I have my turn to present my thing, and I'll share more about what we are doing. Thank you, sir.
Thank you, Mr. Chouhan. I will come back to you afterward. Let me come to the Mr. Ravi Sablaka. Mr. Ravi Sablaka, can you introduce yourself? So it will be better. I have your write-up, but I think it is better you speak so people can understand what you are doing and what is your portfolio. And then we start the session. So please introduce yourself. You are on the mute. Please unmute yourself. Mr. Ravi, can you hear me?
Hello.
Yeah. Now we can hear you. Please introduce yourself.
Yes, sir. Actually, I missed your introduction, sir. Sorry, I couldn't get you before.
But no, not an issue. You will be during the session. You will be get my introduction, so that is not an issue. Please.
No,
continue.
No.
Yeah, Ravi, I can't hear you. Mr. Ravi, I can't hear you. Can you hear me, Mr. Ravi? Can you hear me? I think there is a technical glitch with the audio. Video is okay, but there is a technical glitch with the audio. So we will Mr. Ravi will join later on. So I will start with Mr. Keegan. Please start your presentation. I think your presentation is very interesting as you explain the heading of the presentation. So please come to your presentation. The floor is yours.
I'm just sharing my screen. Please let me know if you are able to see the screen. Yeah, hello.
Yes, we can hear you.
Okay. Has the presentation popped up on your screens?
Yes, that is there.
So, yes, so I will talk about the available technology and automation that's available in aluminium scrap processing, which is the basis for aluminium recycling. Let me start today's presentation with the types of scrap that you will generally need to process, or the general kinds of material that you will find in your yards and around the country. So the first one is UBC, which are beverage cans. You have sheet metal stampings, profiles, chips and turnings, foils, trimmings, cast aluminium, wrought aluminium, mixed aluminium scrap, and aluminium from other kind of forms of mixed scrap. In the coming slides, I will run through some pictures so you understand a bit more. So these are coming from the process industry, where you have sheet stampings. On the right is the product after process. So that's kind of a bale that is formed. I will go into details in the coming slide. Sheets from offset printing plates. So these are kind of, there is some contamination in it with some paint and other material. So there are two kinds of ways to process this material. You could either bale it as it is, or you can shred it if you intend to clean up the paint and other contaminants. Chips coming from various machining processes. So those are briquetted into cubes, as you can see. Mixed loose scrap aluminium profiles coming from window panes and other applications in buildings and the newer structures. Engine blocks and parts. I think this picture is from a car company. So you can see some engine blocks, gearbox. More and more cars are using aluminium in their manufacturing components. Scrap, again, another picture of different kinds of scrap. Coils, from the process industries. This is virgin material and nice to be recycled. So here is where Lindemann comes in on the technology and the available methods. You can see pictures of scrap, processed scrap. So with shearing, it's the simplest process where you just cut material. In other words, it's as good as using a scissor on scrap. You can cut it to whatever size. Then comes shredding. Shredding will give you size reduction, densification, and helps cleaning the scrap from contaminants. You have baling, a simple process where you compact scrap. Aluminium as it is very light, and so it gets very expensive for transporting material from your yard into the smelter. Then baling is the cheapest way to process such material. And the last one is briquetting. Briquetting mainly for fines. On this slide, you see how the machines would look like to give you an idea of each kind of equipment. So you see shears, balers, shredders. The right ETA brick, that's the briquetting press. Blow up of machine. So the smallest shear starts from an 800-ton shearing force, and it can go even up to 1,600 ton for 800,000 shearing. So shredding. This is an interesting topic that is discussed all across the country recently with increased awareness and interest and motivation from the government. A lot of people are considering investing in shredding, and I thought let me touch a bit more on this aspect of recycling. So what is done here is you have a rotor, as you can see, with hammers on shafts. So you could have, say, 6 shafts here with maybe 10, 12, or 16 hammers that are rotating on that rotor, which is weighing roughly around 25 to 28 tons, and it rotates at 750 RPM. So it's a ferrous shredder, it's a slightly lower RPM of 600. So what that does is it strikes material against an anvil to crush it into small pieces, and those drop through the grids on top and below. So basically you get size reduction. Baling, you can see the feed box. It's basically cutting off oversized scrap and forming small cubes to increase the density. Briquetting. This is a plant. I think it's a real-time photo of a recent installation in Poland. Coming slide, we'll see more pictures. Yeah, so you can see the dosing bunker on your left, then the press itself on the right. Baling and briquetting both are quite close to each other, but what briquetting does is it ensures that the moisture content in the material is reduced to around 1% or sometimes even lesser. This is important because when the briquettes are going into the smelter, they need to be as dry as possible. On the other hand, it is used to process chips, let's say chips coming out of CNC machines or lathes and so on. So they have contaminants of lubricant and oil and moisture in it. So briquetting is the best way. Other than that, dry material is also processed directly into a smelter where they have this vortex which is created, and you have liquid pumps which charge material into the oven directly. However, by briquetting, the metal yield is also, we have seen that it's around 18% higher than what you would get by simply processing chips into a smelter. So, and again, burning oil is also not good. So most clients nowadays are preferring to briquette these chips instead of just smelting it right away. On the other hand, the size of briquettes is much smaller. So when you have a lot of induction furnaces that use these materials, which we are seeing mainly in the secondary process, where you have small induction furnaces, they are not able to process bigger bales. Bales are of dimension of 300 mm by 300 mm. That makes it difficult. So with such kind of briquettes, the smallest size is about 70 mm, 90 mm, going up to 200 mm, dependent on the requirement. That's how the finished product looks like. This is a chips processing line. So in the first step, you have an in-feed conveyor. The red box there is a shredder. So the chips are shred to make them free-flowing. They are then de-oiled or passed into a centrifuge to remove any kind of oil and contaminants, into another bunker and weighing device. The final red and orange section is the briquetting press. The material is charged, coming out as. So let's look at the economics of these different processes that we spoke about. So the figures are from data that we have collected across several of our machines. However, in recent times, the price of oil going up and everything else getting more expensive, those may have changed a little bit. But overall, it's quite close. So shearing a ton of material would normally cost around 17 to 21 euros. Baling is 9 to 13 euros, briquetting 18 to 25 euros, and shredding is the most expensive process. However, higher the tonnage, then you have a better economies of scale, because the capex is quite intensive on a shredding plant, and it's also a very extensive process, maintenance intensive. So with shearing, you just have better handling. The size is 100 to 600 mm as you want. Bales handling as well as better metal yield. With briquetting, you have handling, better metal yield as well as liquid removal. So essentially, you have dry, moisture-free briquettes. On the other hand, shredding will help you with handling, better metal yield, as well as preparation of material for sorting and segregation. In the coming slides, I will go a bit into the details of sorting and segregation and the technologies that are involved. So why shredding? The aluminium end product is ensured to be clean and iron-free. So in a smelter, this is an important factor where you want the material to be as clean as possible without any contamination. It's iron, maybe copper, maybe anything else. The end product should be chargeable to make mechanical feeding into the oven easier. You get a better, cleaner grade of aluminium, and the melting cost of shredded material is much lower as compared to baled material. That's a typical layout of an aluminium shredder plant. So you have the in-feed conveyor, the drive motor, the vibrating conveyors, screening drum, belt conveyor. You can also have magnetic separation by a drum magnet or overband magnet. On the side, you can see there are some noise absorbing poles and an overhead crane for maintenance. Another view of the shredder plant. So what this includes is treating of the shredder heavy fraction and the light fraction. So when you have a mix of material that is coming, that needs to be processed. For example, when a car is recycled, you have ferrous, you have aluminium, you have seats, glass, rubber, tires, copper from the motors and everything else. So that's where you, or if you are recycling, say, a washing machine or white goods, refrigerator, and so on. You have copper along with aluminium and everything else. So the shredder downstream then has different technologies to recover aluminium, and most of you might be familiar with Zorba, which is a name for a metal mixture of aluminium, copper, zinc, and brass. A 3D view of a basic shredder. And this is also an installation, I think a recent one we have done in Europe. As you can see, there's an in-feed conveyor, the shredder, and then the dedusting system. So we suck out air from the shredder box, which pulls away dust and any kind of light material such as plastics, rubber, and things like that. And this is then processed the downstream. Layout of the different steps involved in Zorba treatment and separation. So in the first step, you have feeding and screening, separation with an eddy current system. So an eddy current is used to recover aluminium. The next step, you have sensor sorter, and then you have induction current systems, mainly to recover stainless steel. The third step, you have then another sensor sorter followed with recovery of cables. Finally, you can have a second round of an eddy current to recover any more aluminium that's in the fraction. The sorted product, as you can see there on the left, is the aluminium product. And the heavy metal product. Everything else that was not aluminium is sorted in a separate section. We also use X-ray technology. So this is mainly used for sizing. For example, you need to the first step, you size the material coming out of a shredder into two fractions, one between 10 and 30 mm, and the second one between 30 and 100 mm. You have an X-ray tube that activates the valves that are under the belt. So there is a jet of air which is blown across material to sort it into the two bins, as you can see. Once the material is sorted or you have done the sizing, then in the next step you have X-ray imaging process. So this works on atomic density parameters. So the details are fed into the system, and that compares the atomic density to the actual material that's on the conveyor belt, sorting it into each channel. On here, I try and mouse. Can you see my moving there? Okay. So around here, the red mark is a small nail. So when you have these profiles coming from buildings and so on, they have some screws in it. So this can actually be a big problem for the smelter. And thus, X-ray imaging helps to ensure clean material coming into the smelter. So this is a better picture here. You can see the nail. As well as you can use it to scan and separate other materials such as copper, zinc, and brass. Fractions that you can see. So the environmental considerations, why go into all this headache? Aluminium is one material that can be recycled infinitely. And so the data here shows that you have roughly 95% savings in energy cost when 10 tons of aluminium is processed with recycling as against producing it from ore. At the same time, when you recycle steel, also it is 55% lesser in energy consumption as against producing 550 metric tons of steel from normal ore. It reduces carbon emissions. Scrap processing improves the melting process, so lower melt time, less losses, lower specific energy consumption. Pollution control with dedusting systems, and so on.
Mr. Keegan, please a little bit fast because we have.
Yeah. So I think I'm at the end of it. So
Okay, thank you.
So that was all about the technology, and this is a slide about us as to where we started. So we are
continue.
in Düsseldorf. We are the inventors of these machines. The first machine we made was in 1930. Ever since, currently we have 2,000 active machines running worldwide with 185 million tons of steel that is recycled on our machine. So that's the equivalent of 25 Eiffel Towers. 380,000 bales are produced every day on our machines. That's our experience. So, and this is our network. You can see I'm there in UAE. Thank you for joining, Lindemann, and thank you for your time, gentlemen.
Yeah, thank you very much, Mr. Keegan. I have some question for you, but I think it will be question session will be the later on after completing the thing. So it will be better to we can save the time, and cross question should not be or question may not be repeated. So I think now I will call upon Mr. Chouhan. So Mr. Chouhan, please continue. Floor is yours, and for your presentation, please.
Rajpurohit, thank you so much. And let me share my screen first. I have compiled a few slides, not only on R&D, but about JNARDDC also, because we would like to introduce ourselves to the forum. As I said, like we have been nominated by Ministry of Mines, and the whole recycling sector, the secondary aluminium sector or the non-ferrous sector is looking towards us that what we are going to do or how we can help, specifically being the R&D center so far. So once again, wishing you all a very good evening, and this is the Institute Jawaharlal Nehru Aluminium Research Development and Design Center, set up in 1989 by Ministry of Mines in technical collaboration with United Nations Development Program. Till 1996, this institute was focusing on upstream research that was related to extraction of aluminium, say the Bayer's process or the refinery activity, or aluminium through electrolysis process. 2000 onwards, there was a national task force, and the downstream division came up, and we also started working on the metal side. And then in 2020, you can see on your screen, it's a landmark year for us. And we have set up a research extrusion press, but it's actually a commercial press, 1400 ton or 14 meganewton extrusion press. And in 2021, Ministry of Mines nominated us as a metal recycling authority, and we also established ourselves as a cold refractory lab. Then in 2022, some assignment from Ministry of Mines, that is the idea of Niti Aayog, circular economy in the metal sector, where we are dealing with the various draft guidelines for aluminum, copper, lead, and zinc industry. This is the administrative setup of the institute, where general body and governing body, the chairman is Secretary, Ministry of Mines, and then we have various members from academic institute or industry for our research advisory and project monitoring committee. Dr. Anupam Agnihotri is our director. And this is the building. Those who have not seen it, those who have not visited us, we are spread in 100-acre total area, and 20% is dedicated to this research lab. I hope the video is smooth. I'm not sure if then objective and missions and visions that I will skip, but here the fourth objective, where you can see that provide assistance to both primary and secondary aluminum industry and provide analytical services. So we are currently focusing on the recycling sector more compared to the primary side. And in the downstream side, if you see, we are working on metal farming, casting, alloy development, characterization, and our chemical and mechanical testing facilities are 1702517 accredited. And soon we are going for this 17034 2016 accreditation. That is the accreditation for reference material producer, because we are going to produce reference material for spectrochemical analysis of aluminum alloys. In the downstream division, we do development and indigenization of aluminum alloys, melt treatment and grain refinement, casting, forming and joining, and heat treatment, extrusion, simulation, die design, recycling and anodization. Some of the facility we have full setup for extrusion, except the casting part, like die design, simulation software, deform, extrusion press for validation, metallographic laboratory, mechanical characterization, electrical conductivity meter, scanning electron microscope, optical emission spectrometer. This OES is very unique one. This is a PMT based equipment, and forum will be surprised that even one can find 40 element calibration for aluminum alloy, perhaps rare, and you will not find it anywhere in the world even. So we also have a 50 liter anodization tank and heat treatment or the melting facility. Some of the assignment from Ministry of Mines, like we have been nominated Metal Recycling Authority, we drafted various documents which Ministry or the NITI Aayog subsequently published as a strategy paper on resource efficiency or national non-ferrous recycling framework. And Ministry of Mines, regarding this circular economy agenda or the metal scrap recycling framework, they are very regularly following. And coming to now the actual part or the R&D part that I'm going to talk about, let's have a look at the value chain for the aluminium. Here, what you see that the metal for product manufacturing is coming from the primary or the upstream side and the secondary side, and of course at the end of it, end of life scrap, after you use it in various applications, building and other say auto, all these are coming, and these for recycling. Even the pre-consumer scrap or say the process scrap or the some people even call it prompt scrap, comes from the downstream for recycling. So why do we recycle? If you go to any forum, people will say that aluminum can be recycled infinitely, it is very good for recycling and so on, and there is no deterioration of property, it saves energy, it saves this emissions, everything is, but what if you see on the right side of the screen, the recycling has a high economic value. There is a scrap for recycling, and of course there is a demand for it. So this is the main driving force that we look it as, and these are the of course incentives associated with the recycling of aluminum or any other metal. Recycling looks very simple. Even the kids or the students or the even say like pre-primary in KG1 or so, they are taught some kind of recycling concepts as a in the schools today. So people think that recycling is just collection of end of life or the process is scrap, do some kind of a dismantling, detach it from, say if it is a wheel or some part of a car, take it out, rubber or so. Then you have to remove, of course, foreign material before remelting it, putting it into the furnace. And once you are ready with the molten metal, you put into say casting or subsequent forming applications for product manufacturing. But each and every step is very, very critical. Say it the scrap collection, import is one of the source for the country for the time being, and then manufacturing discards, domestic scrap auctions is one, then municipal wastes, even our medicine bottle, the cup syrup bottles which has PPK goes as a municipal waste, कचड़े वाला आ गया, चलो गाड़ी वाला आ गया, कचड़ा निकालो. So all these PP caps, you'll be surprised to know that this goes as a municipal waste. Then all our electrical fans or the ceiling fans or the refrigerators for which there is no buyback option is going to the community scrap dealer, जिसको हम लोग कहते हैं कबाड़ी वाला. And even some people, some rag pickers जो साइकिल पे आते हैं घर पे आपके, वो आपकी utensils यह लेके जाते हैं. So ultimately this is the requirement of the country, that scrap collection system. Every forum you'll hear the same thing, and based on the life cycle of the where building and construction, average life is 40 to 50 years. Transport sector, if you see, nothing is less than 10 to 15 or so, except the packaging sector or the so. So the life cycle of the product span or so is very high. So this aluminium is what we used earlier will obviously come back, and there has to be some kind of a collection system to be devised for the country. Then dismantling, like my previous speaker, Mr. Keegan, has given very good presentation about the shredding and the briquetting and baling. So these are the area, like we have to be very, very choosy about the technology. Say sorting, there are a number of methods. We are currently resorting to this hand sorting only. Can be the air classification, magnetic separation, heavy media separation, automated like laser based, color based, X-ray based, shape based, artificial intelligence based, what not. So all these areas are open for R&D. Then the melting side, say degazing, filtration, the alloy addition, grain refinement, everywhere. Like in some of the meeting when I was there, some people approached me saying that whether JNARDDC can give customized degazing setup for their furnaces, because the degazing setup is specifically are manufactured in a big by big OEMs, I will say, and it is not customized. It is they're giving based on some volume basis or so. So somebody asked me whether some kind of a trolley which has a degazing system today, it is operated in this plant, to tomorrow or the second shift it is taken to the other plant. So that kind of system has to be adopted, or that kind of setup has to be devised for the Indian conditions, where the size of the units are really small compared to the developed countries, where the melting capacity is multiple of the tons, or the size of the furnaces or equipments are really larger. But here, if you go the crucible furnaces, small handi furnaces or so, how do we degas it? So that kind of customization in Indian context is required. Then remelting, we have, as I said, like various furnaces, say it a rotary furnace or the electric furnace, or the fuel fired furnace, or even the moose furnaces. We have seen even the wood fired furnaces used somewhere. Then forming, there is an issue with the forming operations. So some of the pictures we took during our visit to various recycling industry, what I said during my introduction. So we visited with help of MRAI. We picked up all this. Thank you so much. I would like to, in fact, thank MRAI for this support. To give the real picture of the industry. You can see the various wastes in the scrap. Maybe it is iron contamination, which may require shredding or various kind of a sorting technique, because iron is one of the critical element, and it needs to be tackled properly. Otherwise, not only deterioration of the property, because it can give iron related intermetallics in the material, but also material is more likely to be off grade, and it may not fit into the grades of various standards, be it Bureau of Indian Standard का कोई इस grade हो या कि फिर industry standard, whether the automobile industry is asking for some grade. If the iron level is high, obviously nobody will prefer to take such material, some build material, or even see how the local industry is doing. They are taking one piece manually and detaching the nuts and bolts with some part of this. So the dismantling or the threading or this kind of devices have to be literally adapted to the Indian condition, so that one small recycler who is not really capable of going for such a huge capex, what Mr. Keegan says that capex is one of the concerns, and that is what is the need of the industry. Then, of course, this is the unique picture of Indian recycling industry, that ladies are there picking up the various material or various grades of metal from the conveyor, and this is how it is sorted. And some more pictures, like some kind of mechanization is done where you can control the speed of the conveyor, take help of some kind of forces to separate the material by gravity, lead removal. All these things are really good. What we observed, some compactors we saw, and then how it is washed, everything. So why I am projecting all these pictures to you, sorry, that even people are doing this kind of casting, taking this chammach spoon from the furnace, directly making book casting and then rolling. And do you think that this material will be good enough for the rolling when they roll down to 2 mm sheet or 1.5 mm sheet for some utensil or some packaging thing? Then how the chips are melted, you can see the utensil industry, how they are doing. I said that wood fired furnaces are also used, and the utensil industry, you will see that some big industries are also using environmental units, doing the liquid metal supply, molten metal supply. And during our survey, we found that this is the cost of the scrap, which can be 10 to 25% of the LME, and overall cost for the recycling industry, the breakup could be this. And the total secondary production is say 1.5 KT, sorry, 1.5 million ton. So here the various users, say like building, construction, industrial, and say the product wise extrusion, rolling, or the casting. Of course, the casting mostly goes to the automotive sector or some to the industrial sectors. And this is the numbers gets changed when people say that the utensil sectors are not included in previous numbers. So this is also one of the conflict that I will talk little later. And this is the overall consumption pattern, like mostly it is going in the transportation 60 to 70%. And if you see the global numbers, here still there is a scope to improve the numbers for various sectors. And this particular chart or the table, if you see, the India is #1 recycling industry when it comes to aluminium today. And the pictures what we saw, or the discussions we are doing here, is not really supporting to these numbers. Because if India is #1 recycling, then it has to be #1 in all aspects, be it the quality of the material, be the practices of the recycling industry, or environmental concerns, or every related aspects. We need to be #1. That is what the government of India thinks. That is what Metal Recycling Authority or JNARDDC thinks. So some of the issues are challenges, like I said, like every forum there is a concern how to collect back, or say the reverse logistic for the scrap or end of life material. That is one of the area for research, not only the core metallurgical research I will talk about, where we have to deal with the iron or the contamination or off-grading of the material because of unwanted, undesired element going into the metal. So this area is also where a lot of research is required. Like we say in the country, the end of recycling rate is say around 25 or 23% or so. That means the reported value of 180,000 tons of material coming back for recycling. But we did some calculation, or we took the numbers from various sources and found that this much scrap should be available. But where this scrap is going, I mean, so number one is the information related to the recycling industry, the data, the numbers related to the recycling industry, and the technology gaps. You see that how some of the industry may be operating. They are just taking this metal, not even bothered about the draws or the inclusions going into this casting, and further they will be rolling down this to make utensil. This is movie or the video is from one of the utensil manufacturer. And while we have some reputed or very good recycling industry setting up example where they are supplying molten metal to the nearby die casters as well as in-house casting. And the technology gap, we have been working for various aspects of
Chouhan sir, a little faster. We have
sir,
short of time, please.
Yeah, sir. Give me some. We are drafting various guidance documents which will be subsequently published by Ministry of Mines or MRAI, like minimum infrastructure requirement, minimum recycled content requirement. Now, this is one of the area like minimum recycled content requirement. When government is helping recycling industry to say that any particular product of aluminium will have certain minimum recycled content. So we've as a research institute, we foresee this area to have lot of R&D requirement, that the area where the aluminium or the recycled content has not penetrated, we have to explore that area. I have to skip all these slides because previous speaker has already touched upon all this area. Like for the recycling industry, various concerns are the cost, of course. So we foresee the R&D needs of aluminium industry is the one to address the collection or the reverse logistic of scrap metal. Then of course cost optimization, because although they are the small recycler, but they are also losing lots of metal by improper practices. Then industry is looking for the mechanization, and the large size recyclers are looking for automation and instrumentation, but the country is looking for the quality in the recycled material, and maybe some artificial intelligence can also help here. And this one specific slide, I'll try to attract the attention of the forum here. This is the analogy I have tried to create with the cycling and recycling. So if you go up the hill or cycle up or go down the hill or cycle down, which is the more rewarding, perhaps everybody can have the simple answer. Same is the case with the recycle. If we try to upcycle, you will have better rewards, so better prices for the material. But if you downcycle the material, if you downgrade the material, the same material you'll have to sell for less. So this is the upcycling area, like the hydro is doing. Some earlier speaker in the previous session was talking about the branding, like hydro is doing the circle or this restore, all this kind of a branding they're trying to bring to the recycled material. that kind of a branding MRAI is also envisaging for the Indian context, for the Indian recycling industry. This picture you see that how to promote the recycling or the secondary sector. This Forma Fantasma, one Italian designer studio, has used the recycled product to make this bookshelf. Maybe MRAI should also promote the recycled content. They should also get help of some popular design studio or the designer in the country. And then very latest news from the Alcoa side, very interesting slide. They are challenging to have one process as something, and they are claiming that this material, any grade of material can be beneficiated up to LME grade of P0101 grade, almost like 99.9%. So scrap aluminium is not really a bad thing that can be upgraded to very high purity metal, provided we do better sorting or better melt treatment or better melting practices. JNARDDC is doing some projects for the recycling industry. Just 2 slides and 2 minutes. This is one area.
Make it fast, please.
Yeah, so JNARDDC has recently taken up one recent research project for undiluted recycling of cast aluminium alloys containing high Fe impurity suitable for SMEs. Here, the iron is one of the culprit or contamination that we want to deal. We want to filter it out, number one, or we want to settle it with some element so that it doesn't hamper the property. This project is in association with Munjal University, Gurgaon, and the Sri Ram Krishna from Coimbatore, and is sponsored by Ministry of Mines. Then we have taken up one more project for solid state recycling of extrusion for chips, where the Tata is Advanced Solutions, they are aerospace structure manufacturing and generate lots of chips. So with them we are doing this project. And last slide, where JNARDDC is also trying to help the recycling industry by producing the reference material, certified reference material in the country for their cost optimization. So that's all for the time being. Please get in touch with this JNARDDC MRAI. We'll certainly be happy to interact more with the recycling or the technology supplier side as well. Thank you so much. And thank you, Chandekar ji and Metalworld team for inviting JNARDDC to this forum.
Thank you very much, Chouhan ji. Very informative and interesting. And really, this time there's two papers. One is related to R&D and another is for solution. So both are the mad for each other. You are just doing the R&D and solution are ready with Mr. Keegan. So I think it is a coordination between both the presentation and correlated with all. I think we have another 5 minutes, Mr. Chandekar. So we can have some question with the Keegan and Mr. Chouhan.
No. Hello, Mr. Ravi will make the presentation, no? Mr. Ravi.
Yeah. Mr. Ravi is not there, I think. Mr. Ravi.
No, he's there.
Okay, fine. Mr. Ravi. Yeah, please.
Now, Mr.
You are from
Mr. Ravi, are you able to access your presentation now?
No, sir. Actually, I'm having some technical issue.
Anyway, so I will run your presentation. If you,
yes, that would be nice, sir. Thank you so much.
Yeah,
thank you so much, sir.
Yeah,
please.
We will run your presentation and you just.
Sure, sir.
Okay.
Okay.
Just a minute, I will. Okay. Right.
Yes.
Yep.
Yeah. You just start your narration. We'll change the slide. We'll forward
yes,
the
sir.
slide.
Okay, sir. Thank you so much, sir. Sir, as we all know that aluminium is the most common material, and most of the items like in aircraft, high-rise building, household items, and consumer electronics, we use aluminium in that. So can change the slide, please. Next slide, please. Next slide, please. And as we all know, that it's the most abundant mineral on Earth after oxygen and silicon. So, and globally, it's only behind iron and mostly used alloy in the world. Next slide, sir. So there is a bit of aluminium everywhere, sir. Aluminium and its alloy are used extensively in manufacturing of high-tech warships, aircraft, jet engines, consumer appliances like refrigerators, air conditioners, kitchen appliances, power lines, and many more items, sir. Can just slide, next slide, sir. Okay, what do we do, sir? Actually, we are converting scrap. We are recycling scrap into aluminum alloy ingots. The thing that you see in front of you are the ingots, which are of different grades. And by ingots, when combined with other materials, aluminum really shines. An alloy is a metal combined with additional element to create a new material with superior quality. The alloy will be stronger or have a higher melting point. The other commonly used metals for creating aluminum are, which are basically mixed with aluminum, are bronze, copper, lithium, manganese, magnesium, silicon, zinc, and a few of metals frequently utilized for making of alloy product. The alloy enables the aluminum natural properties to be improved, enabling it to be cast, forged, extruded, or utilized for welding. So next slide, please. Okay, why aluminum, sir? Aluminum is as adaptable and recyclable as we want it to be. Used for anything from yogurt lids, cans, to automobile engine parts to aeroplanes. It is easy to recycle. It has got high strength to weight ratio, high electrical and thermal conductivity, high reflectivity and resistance to corrosion, non-toxic, ideal for packing and kitchenware production, ductility, easy to cold work and fabricate. Sir, next line. Okay. Now what we do, sir, we actually, we are into recycling business, sir. We recycle scrap, we procure scrap from local market and import scrap. We segregate the scrap as per the requirement and we convert it, we melt it and convert it into different grades used for different purposes like automobile parts, fan components, LED light manufacturing, wherever, whatever grades are required. We mix different metals like copper, zinc, iron, whatever is required, magnesium, manganese, and make those grades, sir. And it is for us, like we started in 2013 in the name of Taran Alloys with a manufacturing facility of 50 tons per month, and we have graduated to 300 tons per month. And we are supplying to basically all the major fan industries, major automobile manufacturing parts, LED part manufacturers, and electrical parts manufacturers, sir. Sir, next slide, sir. We promise the high quality happiness of people and planet. Strengthened by our partner network and distribution channels, Taran Alloys is a leading supplier for prestigious manufacturing companies of fan, LED, and automobile parts in Hyderabad, Pune, and Goa, expanding our clientele to Pan India with the mission to supply the best quality alloy for the wellness of people and the planet, sir. Our work culture, next slide, sir. Our work culture is based on the value of quality excellence. For all kind of product, quality manufacturing is a critical factor. We deliver exactly what you anticipate. In the preceding years, we have gained an experience of advanced techniques, innovative procedures, and a deeper comprehension of customers' needs and demands, the most recent market trends. Our qualified team will work with customers to ensure the greatest customer and premium aluminum product, which will also assist us in expanding our business. We have the best experts for the high-tech manufacturing practice. Taran Alloys offers aluminum and its alloy for various application industries like automobile, packaging, consumer electronics, rail transportation, aviation sectors. Yes, sir. Next slide. Next slide, sir. After this, sir. Next slide after this, sir. Okay, that's all from my side, sir. This was all what I could give you, sir.
Thank you very much, Mr. Ravi. A nice presentation, and I think all the three presentation is completed. And I have some question with Mr. Keegan and one Mr. Chouhan. Mr. Chouhan, as you said that the R&D, so I think we have discussed earlier at many times regarding the DOX product means directly produced from the scrap, not to melt. So I think there is a solution with Mr. Keegan that he shows some small pucks or small briquetteds which can be used as a DOX in the steel industry. Is it possible, Mr. Chouhan?
Yeah, of course. this deox, like what you said, Mr. Purohit, that sorry, Dr. Purohit.
It's all right.
That MRAI is looking or is having discussions with the stakeholders like the recycling industry or even with the ministry, that the secondary, the deox produced from the secondary route in various forms, may be, it can be a rod or waffle or even the bale, can go into the deox product. Like earlier we have tried to make the density more if it floats on the steel, so mixing it with the iron turnings, and so this kind of a combination is possible. And obviously we can have a trial, do some research and see if it works out. We'll put it into our guidelines, that on we can put it to the governments, that this kind of mandatory utilization thing which you are aware of can go from our side.
Yes, thank you. Mr. Keegan, I think it is a good opportunity for you to be approach your buyer and produce such type of things which can be used directly to steel manufacturers, and it saves the cost, because unnecessary melting cost will be added when you manufacture the deox product. So when it can be used directly in the furnace, then why we cannot save this thing, energy and other things? So it is a better opportunity for you. What you say in this thing?
Absolutely. And one of my customers has already taken the first step. We have one of our briquetting press in operation in Raipur already. And there is a lot of interest overall from the market. And if there is time, I can show a video on this process, on how it's done.
Okay, we will see later on another thing. But number two, there's a small question that you are talking about your equipment machinery. So in prospect of the India, I think how you can make the economy and affordable equipment in the India, because you know that there is a small manufacturers, the large manufacturers are very few in the numbers. So can you do something research or something and make us equipment which is partly manual, partly automation for the small recycler, because the number of recyclers are in the MSME. So what you can say in this regard?
So we have an extensive range of equipment. So we start from small capacity equipment also, which is our N series. N stands for new series. We have. Sorry. So, for example, when you look at shredding, smaller shredder that we make can produce about 10 to 15 tons an hour, whereas the biggest one can produce 450 tons an hour.
Okay.
And the motor capacity on the smallest one is 500 HP. It goes up to 10,000 HP.
Okay, thank you. I have some question with Mr. Ravi. Mr. Ravi, are you hear me?
Hear you, sir. Yes, sir.
Yeah. Okay. So how do you see this alloy market and what is the future of the alloy market looking to the scenario? Because the two people are the technical people, you are the commercial people. So my question is the commercial, that how do you see this scenario of future market looking to the LME prices nowadays?
Sir, current situation is quite good, sir. India being growing in the automobile sector, the demand is definitely there. And as someone has addressed that 95% of energy is saved when we convert recycled material into aluminum alloys.
Yeah.
Compared to the aluminum bauxite that we used to convert into aluminum. So looking at this, sir, definitely there is a big demand in hand. All the recyclers are growing, sir. As I told you in my presentation, from 50 tons, we have grown up to 300 tons. We are planning to go to 500 tons by this year end. Definitely demand is there, sir.
So the next question to you also, that are you exporting something or you are selling this material?
So presently we are not into exports, but definitely our aim is to export, sir.
Okay, good, good. So this is nice, Mr. Chandekar. We have some more time, so we can have some question, or we can conclude this session.
No, I think it's a lot of time now. We can conclude the session, but we can at the same time, I think we can talk to Mr. Naveen Sharma from MRAI.
Yes.
Here. So I would request Mr. Naveen also to start his video. Yes, Mr. Naveen.
Yes, sir. Good evening, sir. Namaste,
evening,
Kishore
Naveen.
bhai, Chouhan sahab, Chandekar ji, and my colleague in the industry.
Yeah.
It's a great pleasure. Hope during the day every of our delegate had good presentation and knowledge on processing technology, and it's very happy to know that Metal India is having a great session on recycling, because of late it was never be a recycling, but I hope there will be a full day in recycling in time to come.
Yes. Recycling is a very important aspect of the metal industry, especially aluminium, because aluminium is one metal which can be completely recycled, almost completely, I would say. So
no, sir, every metal, even the copper, lead is even more.
Yes.
And what Chouhan sahab was showing some data on that scrap availability in the country. So I would like to share here that as of now, the scrap available, which is mainly from the post-consumer, is not more than 70,000 tons, as against what is being imported or demand of 1.8 million tons. So, Chouhan sahab, there is nothing like that. Some data creation will, there are hiding of data. Frankly speaking, as you yourself told, that the consumption in our country is in those applications where it will come for recycling in years, 25 years, 30 years. And the main area, which is mainly food processing or transportation, foils or cans, that is not happening in our country. That consumption will not happen in time to come. So, as in my previous remarks in one of the conference we had a few days back at Nagpur also, so Chandekar sahab, I would like to put up some points over here on behalf of MRAI and entire recycling industry. And what I will suggest you that a white paper should go from your side to the ministries which are related to particular this sector, like Ministry of Mines, Niti Aayog, Ministry of Commerce, DGFT, Finance Ministry, and MOFCC. That these were the participants, and this was the pain area, or this is a white paper. So I'll go few on those points, that there is a need to recognize the production done by recycling industry, their job creation and forex saving. So if we go to Ministry of Mines website, so Chandekar sir will notice that they publish data every month. What is the production in the country for aluminium? Okay, and in those monthly data, only the primary data are being mentioned. So what I suggest, that secondary is around 1.5 million and primary production is around 3.8 million. So out of 5.2, it is almost 35% is the secondary production. So those data should go. Now question will come that primary are 4 producers and they provide the data. How will they travel? Somebody has to take lead. Maybe MRAI will take, or Metal India can take. So these data can be given. So once they come over there, so it will get a recognition. Otherwise, what will happen? We'll keep talking amongst ourselves that we are part of 35%. Government knowledge, we are not producing a single kg as a recycler. Secondly, we would like that conference should recommend that there should be a dedicated desk at Ministry of Mines level, at least at the division level, not at the JS level, director level, who will see for recycling. Though MRAI has been formed, and I hope this will act there in the ministry. And next point is that a minimum recycling content policy should come. So which is already there in MRAI, this thing, but let it go through various sources. We should keep repeating it. And of late, few of the policies have already come that are being released by MOFCC. One is tire recycling, another is plastic recycling, and e-waste recycling, and now of battery recycling is also coming. Everywhere they are talking about EPR and minimum recycling content MRC, and that we should also recommend that. Then major challenge or the fight comes that import is being done in the country. Why import is being done? Because it saves energy, it creates less carbon footprint, and our consumption is so less that there is a need to fill up that demand, which is mainly coming from the casting industry, automotive. So how we can create more scrap in our country? So there should be focus in demand creation of downstream products in our country. So like per capita consumption in our country is very low, and that too also electrical segment. So there is a need to increase consumption in food packaging, transport, building construction, and that can only be possible when aluminum replaces its competitive material, maybe steel or wherever it can be used. So our suggestion should be that government can lower GST on sheets, extrusion, foils, can at least for 10 years, because this goes to the consumer. Consumer don't get GST credit, so that will create the demand. Then we will able to have more aluminum in time to come when it goes to foils, cans, or such applications where it can come for recycling within a year, or maybe can industry says that they recycle within 3 weeks. Similarly, other area of development is that China's alloy demand is huge, and of late their cost of production because of labor cost has gone up. They have shifted their focus to value addition, and we can grab that 1 million ton of alloy market in India. So that low skill labor from India can give good amount of jobs, healthy volume of export. So government should form a long-term policy, maybe 5 years at least, because every year what happens, we are not sure that this budget there will be change in duty or not, whether they will put some impediment, maybe in the form of BIS or other form, or some type of barrier which may not be financial but maybe other type of trade barriers. So government should guarantee, look, we will give this industry status quo, whatever is duty you keep that only, whatever the policy of import will keep that only, at least for next 5 years. I'll tell you, a lot of investment will come, and we will able to grab that market of recycled alloy from China, Japan, and other developing countries. So these are some of suggestions from our recycling industry, from MRAI, which can be sent to ministry at various levels through your magazine.
Yes,
Very
nice.
Fantastic. And yeah, Mr. Rajpurohit, you were saying something.
Yeah, Naveenji, very nice points you have raised, which is really very interesting and very actually we need it. We are demanding since long back, but I think we should go from the multiple platform. It is not possible if we go for one platform. So I think we have to focus all this platform like JNARDDC, Ministry of Mines, and Niti Aayog and other association organizations. So that will be collective. If the efforts will be definitely work, and as we discussed earlier also, that it is needed, basically needed, and we are facing some problem, which is that against primary versus secondary. So this debate is still going on, and that is the big hurdles in between these secondary and primary and these secondary business. So we all well aware of it, and now we'll definitely find out the solution of it, and hope that Chouhan ji and other people and those will be pushed this matter through the ministry also. And I think we have already attend the meeting with Naveen ji. You also are there with the Chouhan sir with the other things. So I think anything else, any more question from other side or anyone?
No, I think we have already crossed the time schedule also. So
okay.
I think, let's close it down. And of course, as you said that the tussle between primary and secondary, it is never-ending story, sir. It will always remain like that, and we have to live with it. And because everybody has to protect their own interest, so they are right in their own, both are right in their own way. So let us go along with that, and let as an industry we have to think. The bodies like us should think as an industry, not as primary or secondary. So we have to take both of them together along with us, and that is how
that's why Chandekar ji, I told that in my first point we told about demand creation. I am talking about whatever is being produced in downstream. The DST benefit should be given, because once this pie become bigger, then there will be no fight. So what I'll do, I'll mail you these suggestions to you.
Sure. We will definitely that also.
Anyway, thank you very much to all, Mr. Viga, Mr. Keegan, Mr. Chouhan, Naveen ji, and Ravi also. And it's a nice session and very informative, very knowledgeable, and hope that this type of interaction will be continue in future also for understand the trade and industry and the challenges and R&D which is going on, and the new equipment, like we can show some equipment which is really useful in the Indian prospects, and that will be again help to the trade to promote and protect. Thank you to all.
Thank you very much. Thank you all the speakers and Mr. Rajpurohit for fantastically coordinating the session, and thank you Mr. Naveen for your expert comments on recycling as a whole and how we can take it forward. So thanks all, and that brings us to the end.